Hello, my fellow YouTubers. This is Roy back again. Just want to give you a little update. So here's my Walter Russell setup here. And the reason I'm calling it a Walter Russell setup is because what we're going to do here on this fine mini experiments is we're going to take a dipole and we're going to create one horizontally. And that'll be the axial here. And then on the rotation, like a Ferris wheel here, the vertical rotation, all the magnets are north facing out. And how I came about this is I was doing some reading on Walter Russell and his vortexial process there. And what I realized is if you take the writings from Maxwell and you apply them into Walter Russell, it makes sense because the natural process in space is for dilation, and that dilation takes place with matter and ponderable matter. And what I mean by ponderable matter would be the ether, would be ponderable matter. So if you take ether and look at one side as the reaction to the action, ponderable matter would be the reaction. It'd be this side of the screen. This side of the screen would be the action. So what I mean by that is, so you have your norths here, and this is how this all came about. We're setting it up right now in the Bedini setup. So I got a bifilar here, and we're going to hook it up to 3 batteries. 2 will be the running batteries, and actually 3 batteries. 1 will be the run battery, 2 will be the charge batteries. We'll use a resistor, variable resistor. We'll use resistors also, and we'll also use a transistor, and we'll get this thing turning. So what will happen when it turns? All right, I'm going to draw out a diagram of this whole circuitry and also on the philosophy. So if you look over here, we have a south-facing part of the dipole, and then we got the north-facing part of the dipole. And how I even came up with what side is north, what side is south, was based on natural process. So the natural process is by taking, before I even put the magnet on there, I put the magnet in my hand. That's a big, strong neodymium, number 52, by the way. And I put it in my hand, and you got to be careful with these magnets because they'll just race out of your hand, and you don't want to be in between them. So when I put it up there, look, you can see it just turned. Let's flip it over here. So when you put it up towards the center, it's flipped, and that's the pole. It's natural process. So what will happen is whatever pole this is, the opposite pole turned its way towards it, right? So there's a dipole in there with some kind of spatial relations in that dielectric of in between, even though they're touching, which I could put this here, and I got this round disc that came with these that are in between. So let's go ahead and figure out placement first. And once it go, but that's pretty cool, huh? Let's see where it starts to turn. Right there, that far out. Now let's check on the magnets where it wants to turn. So look, it's already. I don't know. It seems stronger in the center to turn versus here. Now remember, there's a core here, laminated core. My coil woundings, we'll get into that. I'll draw up the circuit for this. This is going to be a cool bunch of experiments. So the natural process here is for it to be that pole. So we're going to go ahead. Oh, wait. We know what side it is right now. We're attach it to the... Oh, shit. We're going to attach it to the plastic. So basically, we want this plastic to be in between. Not really, but, I mean, yes and no. Oh, holy shit, it broke it all apart. All right, we'll just go without it for now. Well, I got a few more of them. But, so what you're creating is a dipole in here. So whatever that metal is, the axial, so if you got north out here, south is touching the metal rim. The metal rim has got metal spokes, metal hub, and then a metal axial core. So that determined that's going to be the South Pole. There's your North Pole. There's your North Poles. So let's imagine this. So there's your horizontal poles. Field streams are going to come over and overlap, come out and overlap. But there's going to be a problem with that. Right now they're fighting their way through the spokes, which has a stream running this way, a vertical stream. Now hear me out. So when you put this in motion, depending on which way you turn it, the field lines are going to come out and come up over. And we're really putting an oblong-shaped, in a sense, stress on the ether. Back to the ether, guys. The ether, to a lot of people, don't mean much. It's not even relevant. Because it's reactionable. To me, I'm looking at the irrelevant side. The reactionable side. Now that is just acting off the induction off the core, the laminated core off that coil. So if I were to put a voltmeter on those wires there, there'd be some millivolts showing up, I'm sure. Or small volts. But you'll see I bought some magnetic film, and we're going to be able to kind of get a visual around this wheel with the magnetic film to look at the field lines, because I want to be able to prove how they're turning. I mean, because this and this side is two ends of a pole, dipole, and so it's going to loop and want to come back over. But it's going to come over once this is in motion. This is going to come over because this here is going to want to push out. I mean, literally push out. So the swath of the center of, say if this is the equator, okay, but it's vertical. It's not horizontal. There's a vertical, but here's your, or you could say this is the equator horizontal. But this is stretching out the field all the way up to here and then coming over and then going back around. And whether or not the paper will show us if the field comes out and goes around like a round bubble, or if it comes up like an egg and goes over. I believe it follows the contour of the field that is going the opposite direction. This is 180 degrees off. Basically, if 360 is a circle, we're doing one horizontal, one vertical. We're going to do a bunch of tests with her, and I hope you will enjoy the experiments. Next time you see a video, it'll be hooked up to my Bedini circuit, and we will have about 4,000 to 5,000 RPMs. We'll have all the tacks hooked up to it. We'll have the voltmeters hooked up to it. Power in, power out. And then from there, we're going to do a dipole expansion. So basically, from this point here and this point here, there's part of the dipole. Oh, one thing. There's another dipole created here with the Tesla, with the Bedini, which now the dipole here was a horizontal, and there's also a dipole between the top of these north magnets and the center there. So you sort of have a cross. But now we're including a dipole. Well, this is not going to be necessarily a dipole because this is going to be north facing and this is north facing. So this is almost like a half crescent wave that's going to be forcing itself upon this wave. This wave will be turning, but be turning because of this half wave is giving it a wall to bounce off of. We're going to get into this. This gets really deep. I don't want to do it all in this 10-minute video. I want you guys to understand that this is going to be really complex. And this will be the start of me writing up all my circuitry. So you guys will have some empirical data to use here on this experiment. All right, peace out. Need your comments.